Regardless to what domain one might work in, AI is one of the hot topics nowadays. However, as we've learned in the previous session, machine learning has been around for nearly 40 years. So why is this hype coming up only now? The short answer is because of deep learning. It is really good in capturing complex relationships among data up to the point where some are barely interpretable. This is why it's very easy to think about deep learning as a kind of a magic box where you feed data and is able to come up with a decision on its own, pretty much. The purpose of this video is to have a glance of what's inside that magic box. And to do that, we're going to use a guitar. So please get ready, get your cup of tea, and I hope you'll enjoy it. So what is deep learning? It's the subset of machine learning based on deep neural networks. The whole idea of deep learning is to have a processing architecture similar to the one in the biological systems. Although there are many structural and functional differences between the two words, the core idea consists in having a bunch of tiny computing components called neurons. Like for the biological ones, we could see a digital neuron having three main parts: input connections, a processing slot, and an output link to send the results of the computation. As it happens in biological systems where we have more than one neuron, we can stack up multiple neurons and have a so-called layer. By connecting multiple layers together, we produce a neural network. The more layers we add, the deeper the network will be. Hence, the name deep learning. When it comes to deep learning, there are two phases we should consider: the training and the inference. In a nutshell, training is when we teach a machine to do something. Inference is when we can leverage the knowledge of the trained machine for real-world applications. For the training, the same learning approaches mentioned in video number 2 would apply. For example, in a supervised learning scenario, we would have a fully labeled dataset. Since machine learns by associations, we will let the neural network see images and provide a guess about what the associated label might be. We would then measure the error, intended as the difference between the answer provided by the machine and the correct one retrieved from our initial dataset. Ultimately, we would use that error to adjust the parameters of the network and reiterate the whole process until the error gets smaller. Was it too technical? I'm sure you're all familiar with this concept. Let me give you an example. I'm sure we all have a friend that knows how to play a guitar. But before playing the guitar, we always have to tune it, isn't it? Now think about the steps required to tune a guitar. We would pick a chord for which we know what the sound would be. We would then play the chord and measure, according to what is our expectation, how far is the guitar from the expected sound. If the sound matches the expected one, then we're good to go. But if it doesn't, we will have to adjust. How much? We don't know. It's an iterative process, and we are gonna quit with the tuning phase only when we are good to go. When the training process is done, we are ready to deploy the guitar and let somebody else passing by picking up and play his favorite song. Now, one key consideration to remember is that in the training phase, we're only playing few chords, the one that we need to tune the guitar. We don't need to play all the songs we would like to play once the tuning phase will be done. That is a very important step because it's what in the neural network world tell us that the training data set we're going to use to teach the machine to solve a task is not going to be the same that the machine is going to be exposed once deployed. There are two main differences between classic machine learning and deep learning. First, recalling from the previous video, in classic machine learning, the final decision of a model is heavily dependent on what features we leverage to best represent the input data. Somehow, feels like most of the intelligence is still coming from the human that picks those features. In deep learning, we don't really have to bother about extracting features, hence there is no risk of filtering out useful information. A neural network will figure out what aspects are more relevant to take the final decision by automatically adjusting the value in the neurons. 2. By construction, deep learning have way more parameters and variables to tune compared to the standard machine learning. Having more parameters to adjust reflects into a higher degree of freedom, which increases the overall expressive power of the tool. Because of this, deep learning is able to capture more complex relationships between data and reach a higher level of abstraction. Hopefully, you might now understand why deep learning generated such a big interest in the market by looking at some of the applications. Image recognition, speech and language synthesis, gesture recognition, and autonomous systems. As you can easily see, most of these applications build their success on the capability of extracting information from multimedia data, such as images, video, and audio records. So now that we know what deep learning is, let's wrap up these sessions by looking at some of the pros and cons of this approach. Due to the neural network's capability of capturing deeper non-linear relationships among data, deep learning can be extremely effective in solving complex tasks based on multimedia type of information. However, this superpower comes with a cost, as the training can be extremely compute intensive and requires a huge amount of data to be completed. Thanks for staying with me up to this point, and happy learning, everybody!